Welcome to the MS SQL Tips webcast, Secrets to Fast, Easy, High Availability for SQL Server in AWS, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips and today's webcast host. Joining me today is Cassius Rue and Heath Carroll from SIOS, and they will share with us what we need to know for a successful, high availability solution for SQL Server on AWS. But before we get started, if you have any questions, you can submit them at any time during the webcast by entering your questions in the question area in your presentation controls. We will try to answer as many questions as possible during today's webcast. If you have any technical issues with the sound or screen quality during the webcast, also use the question area to let us know. If you're not already a member of the MS SQL Tips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Cassius, and he can get started.
All right. Thanks, Greg. Again, it's great to be a part of this webcast. I want to just give a quick intro. We're going to be talking about deploying SQL in the cloud, quick start templates. And I'm, as Greg mentioned, the Director of Engineering. Been with SIOS Technology on their product development team, engineering, leading our efforts for producing high availability and disaster recovery data replication solutions that work across on-premise and cloud environments, virtualized or even hybrid. I've had the opportunity at SIOS to kind of focus my talents across our product spectrum, products that cover Linux and Windows. And I'm also joined here with our lead developer for our cloud solutions and for our cloud architecture, Heath Carroll. Heath is a very accomplished developer and programmer who helps us head up that cloud business and helps us to continue to move our solutions into more cloud providers. So that's just a little bit about who we are and some of our accomplishments. And before we dive into the program, we want to just start with a quick poll. And we'll have Greg push this poll out, but we wanted to ask the question before we dive in. Have you ever deployed clustered applications into a public cloud before? And so I'll give Greg a moment to push out that poll, and then we'll get the results.
Okay, yeah, the poll's out there, so everybody just take a couple seconds and answer that, and we'll share the results. We got a good amount of people voted already. Just give another 5 seconds, and I'll show the results. Okay, so let me share that. So 93% said no, and 7% said yes.
Okay, yeah, so that's about what we were expecting to see with this kind of audience, and particularly about deploying solutions into the cloud. And there's an understandable reason for that. I mean, a lot of customers have business-critical applications, and there's a concern about moving those business-critical applications into the cloud. A lot of customers have large data centers with very specific SLAs and requirements around recovery time, security, and so moving things into the cloud, it typically, with those critical workloads, we've been seeing here at SIOS that customers trying to do that, they've been moving rather slowly. There are some concerns that they bring to the table regarding tolerance for downtime, their understanding of cloud infrastructure and architecture, what's my recovery time objectives, how long is it going to be if I have a failure where I'll be able to recover from that failure. They also bring to the table the standard concerns about security, high availability, how do I handle a disaster, where's my data stored, and then, of course, you want to make sure you have performance. When you're talking about on-premise systems, you've put in the work to get the specs for the hardware, you know exactly what's in the system, how much memory, what's your CPU, processor speed, how fast and how large is your disk, and those are a lot of things that you can control. And so we are aware of customers who have those kind of concerns and have been kind of hesitant to move to the cloud rapidly as the cloud continues to evolve, though, we're starting to see more traction and more people being interested about how can they get to the cloud, what are some of the options, what are some of the things that the cloud might afford them, really wanting to kind of test it out. So again, to elaborate on that, some of the reasons why people want to go to the cloud and think about it, but also have that kind of hesitancy, if we look at compare and contrast, you want to gain what the cloud advertises. You want to gain all of those resource things that you hear, the buzzwords about dynamic allocation, scaling out a cluster, having the configuration flexibility, being able to efficiently do disaster recovery or to expand or contract your nodes based on workload or peak times. You want to have that rapid provisioning. The cloud advertises that there's no more of the sending in a spec sheet to your IT department to talk about what kind of server that you need to match what's currently in your infrastructure, purchasing maybe additional network cards or SSDs or fiber-attached storage. So you're really hoping that you can eliminate that time that it takes to requisition, acquire, configure, and deploy the operating system and applications on a new server. You're really hoping to get away from that time it takes and go with some of those advertised features that allows your business to be more agile, more able to respond to changes in market and changes in customer needs. But at the same time, when we're talking about what the cloud advertises and what you hope to get, there's still some very fundamental items that customers and partners that are considering a move to the cloud are concerned about not wanting to give up. The perception, number one, is of control and flexibility. You want to have all of the positives of moving to a cloud environment, but you want to make sure you still have control of your servers, of your application's environment stack, and also control about who has access to that stack. We're not giving up, wanting to give up any security measures as we move to the cloud. And in terms of flexibility, we also don't want to be forced into a particular architecture. Along with that, of course, you don't want to give up performance. You want to make sure that what you do in the cloud, your application sensitivity to latency, or your application's need for high-performing systems, you want to make sure that you're not giving that up by moving to a cloud environment. Other factors, high availability. Simply moving to the cloud, you don't want to give up making your systems highly available, making your application highly available, and you don't want to give up disaster recovery. The reason being, those that are kind of hesitant to moving to the cloud understand that just having the cloud's built-in redundancy is not enough for their critical workloads. It's great that there are some applications that can handle scaling out and having static content behind load balancers where as the load grows or as a server fails and a new server is rapidly provisioned, you can just have the load balancer automatically direct traffic to that new web server. But then, of course, that doesn't take into account kind of the customers that we're talking about here. Those customers that have a data tier where the data is actually rapidly changing or the data is held inside of a critical database, be it SQL Server is what we want to focus on in this talk, wanting to know, okay, what do I do in that instance? How do I have high availability? How does redundancy help me in this situation where SQL Server just simply can't be made redundant just using a load balancer? What's the answer in the cloud for my data tier? And those customers and those partners who are asking those questions, who are on this call, who are interested in what does the cloud do for me, who've been very, very hesitant, that have been a part of that 90+ percentile of haven't moved any clustered applications to the cloud, they're wondering that question. How do databases such as SQL Server get that additional configuration and guarantee high availability when we move to a cloud environment? How do they help me in the event of a disaster, meet my recovery point objectives, keep my SLAs to my customer, and really and truly, if you're in the IT space or you're in DevOps or you're responsible for making sure that your critical systems are up to date, you want to make sure that there's an answer in the cloud for when your boss wants to know what happened if a server goes down. You want to make sure you never get that kind of call or have to worry about answering that kind of question. So the cloud really doesn't negate, even though there's redundancy there, it doesn't negate the need for HAMDR backup. One of our Microsoft MVPs mentioned on a webinar recently that we are all aware that clouds do have things that happen. There have been incidences where access to cloud resources have been blocked or services have been down for a particular time simply because of human error or something that was unexpected. So simply saying that clouds have redundancy doesn't guarantee that you no longer need high availability, disaster recovery, replication solutions, or just basic sound IT practices such as doing routine backups and making sure that server instances are up to date. And so that brings us to the question of, okay, well then, what are my options if I still have to worry about high availability, if I still need to be concerned about disaster recovery, if there's still the standard operating procedure that has to be followed in order to have a sound cluster, sound application environment, if I still need to do those things, what are my prevailing options? And you think about it, for SQL Server, the workload we're focusing on, it comes down to kind of two choices. You know, many people have deployed SQL before, are probably familiar with availability groups and then using SQL in a failover cluster instance. And those two choices have worked for years being on-premise. Whether that's a virtualized environment or physical servers, availability groups gives you some functionality of just quick failover, a readable secondary. It doesn't require you to have any additional third-party products to make availability groups work. It's all contained within the SQL Server application itself. And then, of course, compare that with failover cluster instances, and you have some additional flexibility above and beyond availability groups. For example, with failover cluster, you don't have to use Enterprise Edition. You can use SQL Standard Edition with failover cluster, and you can protect the entire SQL instance, and it supports a lot earlier versions of SQL Server, and then, of course, gives you that single point of management for creating a cluster and additional cluster resources. So in the failover cluster instance scenario, if your workload includes other applications that need to be made highly available, you can protect those in failover clustering, whereas you're only protecting and making highly available your SQL Server instance when we're talking about using availability groups. But there's a problem. So we talked about the options are basically availability groups and failover cluster instances. And those of you who are familiar with failover cluster instances or who have gone online as this conversation has been going on and did some querying, you know, typically you set up a failover cluster using shared storage. And that's either a fiber attached storage array or some way you have shared storage between your cluster nodes that you have on premise so that you build out your cluster. And that leads us to what's not available, readily available when you go to the cloud. There isn't a shared fiber attached or iSCSI attached SAN in your cloud environment. And you may be wondering, well, if I'm presenting to you that there's an option between availability groups and building out a failover cluster instance, but failover cluster instances require shared SANs, and there are no SANs available in the cloud, why is that still a viable option? And it's made viable because there are SANless cluster solutions. SANless cluster solutions allow you to synchronize the data between cluster nodes, be it a two-node simple SQL Server cluster or a multi-node SQL Server cluster, a SAMless solution makes sure your data is in sync between cluster nodes, either through synchronous or asynchronous replication. And when you add this to a failover cluster, the failover cluster sees this SAMless cluster as the same way it does a fiber-attached SAN. It sees that as shared storage, and it allows you to build out your cluster using the SAMless solution. That, of course, gives you that flexibility of taking the HA in a failover cluster instance into the cloud. So SAMless clustering in AWS looks a lot like having a node 1 running a critical SQL workload in availability zone 1, and having a second availability zone where node 2 resides, and having a witness server that provides you with that kind of quorum capability in the event that the two nodes become separated. It's a way to avoid having a split brain scenario. And that gives you a failover between availability zones, because the SAMless solution is making sure the replication is taking place between node 1 and node 2. And then the cluster, of course, sees that SAMless storage just the way it does when you were on-premise and you had a big honking fiber channel array attached to your nodes, and you had an IT administrator who was responsible for zoning those arrays and making sure only a certain set of systems had access to it, and that both node 1 and node 2 could actually see the storage. SAMless Solutions gives you that ability in the cloud, gives you that flexibility of, once again, being able to choose whether you are going to stick with availability groups and some limited set of feature functionality that it gives you for the cloud, or you're going to go with a failover cluster instance and the additional flexibility provided by storage replication. So if we put them side by side, you have, and we're going to talk a little bit about the SAMless cluster versus availability groups. And SIOS Technology Corporation actually provides a SAMless solution for cloud clusters in AWS. Our SAMless clusters support SQL Standard Edition, which allows you to migrate your critical workloads to the cloud without having to purchase an enterprise license. And you can build out that cluster using SQL Standard, with SIOS providing the replication so that you can migrate seamlessly into a cloud configuration. There's full support for distributed transactions and unlimited amount of databases, the full protection for all of the databases included in the SQL Server instance, including the master model. In addition, one of the things I like to highlight about SIOS Technology's SAMless cluster solution is the kind of built-in intelligence to know that there are parts of the database, for example, the temp database, which you don't need to replicate between cluster nodes. And so SIOS has that kind of built-in intelligence to know not to replicate the temp DB. It gives you this ease of administration because you can go to your failover cluster UI and you can see the SIOS resource, and it's a part of your SQL hierarchy. So migrating between nodes, moving and stopping the resource all becomes simplified because you're operating from a single pane of glass. The one other key differentiator I think that is worthy of calling out, it's on the slide, of course, but if you think about always-on availability groups, and with SQL Server 2016, of course, there's some additional ability to support more than 2 nodes, but SIOS's SAMless solution allows you to go from 1 to n nodes. So you can replicate in a configuration that's a simple 1-to-1, a source and a standby, or you can go to a configuration where it's with 2 standby nodes, a configuration where you have 2 nodes, and maybe in that example you want to have them as 2 active nodes, where you want to have 2 instances of SQL, 1 active on each of your nodes replicating in the opposite direction. that's an availability or option that the SIOS solution allows you to do with its flexibility. The other thing that using SIOS's fanless cluster allows is data replication of things other than your SQL Server. So as we mentioned before at the beginning of the presentation of the webinar, we started talking about if you've got critical workloads, and for example, your data, if it's SQL, but if it's also some other piece or portion of what you're holding on to on-premise, and you're trying to understand, how do I make that highly available? What options are there for replication of that back-end piece, or my particular environment's very special needs for data to be synchronized between nodes in the cloud? And SIOS's fanless solution allows you to replicate data other than SQL as well. So we're about halfway through, a little bit more than halfway through our presentation, and what we wanted to do was to put up another poll for you, just to kind of gauge a little bit about, we know that many of you haven't put clusters in the public cloud before, but just want to get a sense of, has anyone used templates to deploy applications into a public cloud, or used templates for deploying applications? And I'll give Greg some time to push that poll out, and then we'll wait on the results.
Okay, that's out there. Just give everybody a chance to vote. All right, another 10 seconds and I'll close this one and share the results. All right, let's see what we have here. So we have 94% said no and 6% said yes.
Thanks, Greg. I appreciate it. I appreciate everyone for responding. So again, kind of aligned with what we had in the poll earlier, kind of aligned with what we're seeing is you're considering moving to the cloud. You're concerned about how do you get there. You want to know how to make that easier, simpler, and so you have a lot of questions out there. And it can be a little daunting to go from on-premise to doing a cloud deployment. And so one of the things that allows you, or that actually allows you to make that transition a little bit easier, a little bit smoother, is the idea of using quick start deployment templates. And so these quick start deployment templates really are a way to automate a lot of the heavy lifting of configuring your application in the cloud environment. So in some instances, people have used templates before. If you think about your on-premise, if you're in a physical bare bones environment, there have been tools in the past that allow you to clone system images and blast those out onto bare metal hardware. If you think about your virtualized environment, such as VMware, you have seen tools that allow you to clone VM instances and then push those out, and people are able to kind of put batch scripts or scripting around that. Well, the Quick Start templates takes that to another level and takes that into your cloud environment, allowing you to set up reference deployments for your key workloads, allows you to launch things quickly and easily, to deploy repeatably the same workload with the same type of configuration and parameters. It guarantees that if you've taken the time, or it also guarantees that if the Quick Start template that you are planning to use, if it's provided by someone other than your company, it guarantees that those templates have been rigorously tested and that they are going to be using Amazon's best practices for guaranteeing the most optimal security and availability for that instance. They are going to go through on their end the process, and then also require that those publishing templates have gone through the process of using best practices. And it kind of gives you that single click that we're all looking for. We're all looking for a way to do kind of the easy button approach to, I click, I kind of walk away, and things get built out for me, and I come back and it's ready for me to do a POC, or it's ready for my test environment, or it's ready for a development to kind of go ahead and proceed forward. And so while we're getting ready to talking about the Quick Start templates, I wanted to take a moment just to kind of clarify and make sure that we're using the same terminology and that we're aware that the Quick Starts are different from Amazon's machine instances, and or AMIs or AMIs, depending on who's pronouncing it and where you're at. But the machine instances are available for purchase on the marketplace, and they represent a base image or a gold image for your software configuration. And these can be added to an existing deployment. You can use for example, the SIOS AMI for SQL, or the SIOS AMI to deploy a new SQL Server cluster in AWS by purchasing and agreeing to the terms and then deploying 2 AMIs and building the cluster manually. But also these AMIs can also be used by the Quick Start templates. Quick Start templates can consume AMIs as a part of their deployment process. So I just wanted to clear up a little bit. The AMIs are available to purchase, and you can always deploy those manually. The Quick Start templates are going to be what we'll display a little bit later. We'll give you a demo of using the Quick Start templates, and my colleague Heath will actually explain a little bit about the AMI being used underneath. So all of that's really well and good when we talk about Quick Starts and AMIs and base images for your software, or gold standard, or best practices. All that's well and good. It's all well and good, except for we have to have some sort of a use case for doing all this work. We have to have something we're going to gain, some benefit by having a Quick Start deployment or using these base reference AMIs or AMIs. And the use cases include test and dev. So any number of situations where you're a corporation, where you're pushing out software, or you have an environment that your quality assurance department uses and another environment that your development team uses. If you're in that quality assurance role, you're very familiar with the developer phrase, "It doesn't happen in my environment." You're also probably very familiar with the QA person's role of, well, I set this up this way, or vice versa, of not being able to know how systems were configured. And if you're in that kind of IT control space, you're also aware of where you have certain policies and you want those policies to always be rolled out consistently. That's the use case that Quick Start templates give you. They give you the ability to have a solid implementation where you've done the work to define your network, your availability zones, your address ranges, your security groups in the cloud, and you can deploy those consistently between your test group and your development group. It's also a great way to deploy a 2-node HA cluster using SQL Server Standard Edition. Again, because it doesn't require you to use an enterprise license, it's a cost-effective method for quickly deploying a cluster into the cloud. And as I mentioned, rapid proof of concept. You have a critical workload. It's been on-premise for your entire time at the company. You want to take it to the cloud instead of purchasing more hardware or purchasing the next round of hardware for your hardware refresh. And you want to prove out to the key stakeholders that not only can you take it to the cloud and gain that flexibility and gain that scalability and freedom of the cloud, not only can you realize the cost savings of not building out another data center, you want to quickly show your key stakeholders that you can spin up a cluster, you can provide the high availability, and show the disaster recovery going on using your POC concept data. You want to be able to build that out pretty quickly. And of course, we all know when you're trying to do something new, that window of having someone's ear and needing to prove it out sometimes can take can be a very short window, and you have to make sure you hit that window while you have eyes and ears present. Quick Start templates are a great way of doing that rapid deployment of a proof of concept. Just before we move on, just a few other use cases that come to mind, and in fact were reinforced recently with some customer cases, is having that kind of repeatable reference deployment. A customer rolled out using Quick Start a set of cluster nodes, and then later wanted to be able to go back after they've done the proof of concept and they're ready to move this into a production environment, and even another case where they wanted to add on to a production environment. Being able to go back and easily repeat the steps that you did before to build out another cluster where it's identical to what you did for the proof of concept in terms of how the cluster is laid out, what nodes are a part of it, the replication is configured between the nodes, and you know and have that confidence that what you did for the POC will be the same thing that you're able to accomplish by rolling those nodes out again, or what you did for the first application that moved with SQL as its backend and Department A, you know and have the confidence that when you're ready to migrate that workload for Department B, you can do that without feeling the jitters that come with, well, what did I click here? What did I choose for this setting? You have that reference template that allows you to deploy it quickly. You can also, as part of this with Quick Start templates, say you have deployed a 2-node reference cluster and then decide that now you'd like to add a 3rd node, where you can pair the Quick Start template deployment with one of the AMIs that you purchase off of the marketplace, and that allows you to quickly expand your cluster to a 3-node configuration without, again, having to go through the hoops of acquiring additional hardware, making sure it passes a cert, getting it installed, brought up to speed, and having your IT person sign off on it and bless it and turn it over to either dev or the DevOps team to do your deployment. So those are just some of the use cases that we have seen and experienced from our perspective for using the Quick Start templates. And I'm sure there are numerous other use cases where creating a reference architecture, going through the work of deploying them, can be used to cut down the cost of going to the cloud and also lower the barrier of entry in terms of someone's understanding of how do I actually configure these VMs in the cloud. So that's another key point to remember as we go through. How do we make moving to the cloud for those critical applications highly available? How do we get disaster recovery? And how do we make it easy, simple, push button, right on through? So we're about 3/4 of the way through our time and wanted to make sure we left enough time for both Q&A and to give you a live demo. So I'm going to turn over the presentation controls to my colleague Heath, who's led up our effort here at SIOS for creating these gold standard reference template deployments for one-click deploying a SQL Server cluster into the cloud using SQL Server Standard Edition. All right, thanks, Cassius. All right, hi, my name's Heath. I'm an engineer here at SIOS Technology. I'm going to go through a second and I guess briefly explain what I think the typical way that you would do this on-premise and in the cloud if you were going to do it by hand. If you have an IT specialist or you have a cloud specialist that's been putting your stuff in the AWS cloud space, then they're going to have to spend a couple of hours typically coming up with some kind of deployment diagram, vetting it with the DevOps team, vetting that with whoever's actually holding the purse to make sure that this is what you want. And it might look something like this. It would be a AWS region, say Oregon, with a couple of availability zones, just use 1 or 2, so that you could have this highly available cluster in your space, and then so that you could abide by AWS and general industry security standards, you would have a couple of public gateways, public subnets with a gateway attached to them so that you could RDP into a jump box, therefore separating out your availability domains into a public and private space, where the private space where all of your actual workload is going on could not be reached outside of this AWS area because you don't want it to be contactable for security purposes. Well, you would have a public zone separated with a jump box in it. You would log into the jump box, and then from that jump box, log into either your domain controllers that are serving your DNS entries, or into the node itself for one of your cluster nodes. So on this diagram, this is represented by these remote desktop gateway nodes. And then you've got down here in your private subnets, we've got the domain controller for this subnet, and then your primary SQL node. And then over here, you'd have your backup domain controller and your backup SQL node. I'm not sure how long it would take your standard IT person to come up with this diagram, but part of the development phase would be finding out how many IP addresses you would need in each subnet. This has kind of been done for you. Like you can see here, this one's been labeled as 8,187 IP addresses available in this subnet. You can create more subnets to reduce this number based on your actual needs. But this would be basically what they would do. They would come up with the IP range and then figure out what they wanted to assign to each one, come up with the IP range for these guys, again, assign them, come up with the IP range for the whole virtual private cloud resource, the CPC, and then they would move forward once it got approved and start creating all these resources by hand in AWS. Speaking from experience, something at this scale, which has 5 or 6 nodes in a single VPC across multiple availability zones in a single region, would probably take 2 or 3 hours just to get it set up and configured outside of development of the actual idea. From someone that's experienced, plus another 3 or 4 hours to actually deploy SQL in the way that you wanted it, and then a couple days to a week for testing. All right, because if it's something that they've come up with off the top of their head the first time they deploy it and they set it up, there's going to be firewall rules that aren't set up right. There's going to be security group rules that are probably not set up right. There's going to be some pain to go through before you actually succeed in getting this done. So all of that has been done for you with these quick start templates. All right, this is basically what the main template that I'm going to show you guys does. It creates all of this for you with most of the information filled out. It leaves some important stuff blank so that you can come up with that, like domain admin name and user password, stuff like that. But the way that you would do this is first you would log into the AWS console, and then you would go to this page. This is AWS Quick Start Architecture SIOS Data Keeper. That's the one for hours. You could find it just by going to the aws.amazon.com/quickstart page and then browse for it. You could also go to the Amazon Marketplace. I should probably go there now. All right, so go to AWS Marketplace homepage. Some of the things that you might want, if you were searching for something that worked for this, you would be looking for high availability. If you knew that you were specifically looking for hours, you could search for hours specifically by name. So we have 2 AMIs available for things like this and a quick start template. These 2 AMIs are, one is a bring your own license, so that you would basically contact us, contact our sales department. We would give you a license for it. You would put it on the nodes that you create from these base images, and then move forward. The other one is a pay-as-you-go. Technically, they both have free trials. If you contact us, we'll give you a free trial license for the BYOL. If you go through the pay-as-you-go one, there's a free trial period available for that via standard AWS AMI practice. But those would be how you would get to that. You would have to come to these first. Part of the quick start process before you go ahead and deploy now. One of the things that some of this fine print down here tells you that you need to do is you have to go find the actual AMI that you will be pushing with this and agree to the terms and conditions for its use. So if you try to do this without
going to the AWS Marketplace, finding your AMI, for example this, and then going to continue, you won't be able to. All right, this button typically takes you to a page that says, do you agree to these terms? You have to agree to these terms in order to push this. Go ahead and launch this image and agree to the terms. It does not for me anymore because I've already done that, obviously. So it just takes me straight here, right? So you would have something similar to this that says you'll be subscribed to this software and that you agree to the use of this software and is subject to the pricing terms and conditions, et cetera, et cetera. You would click on something that looks very similar to this, if not exactly like this, and then you would come back to your template page. All right, so once you're back here, there are two ways you can launch this. One is if you are, say you are just starting to migrate your data to the cloud, you're going to need everything, right? You're going to need all of the bells and whistles included in this diagram. But the other major use case is you've already got stuff in the cloud. You just need to migrate a SQL workload into the cloud. So you don't need all of that. You've already got the VPC, you've already got some public subnets, you've already got maybe even some private subnets already that you don't want to get rid of. You just want to add to. So the second way, this second link right here, will deploy just this gray section. All right, it'll deploy just our product, the SIOS DataKeeper replication product, into a SQL Server cluster. It'll just do that into everything else that you already have. All right, so that's obviously for more advanced users that have some experience, that have some stuff already in AWS. But for this one, since most everybody has not used templates and most everybody has not deployed a clustered application to the cloud, I'm going to use the full-blown template that deploys all of that. And you just click the Deploy Now button, and that'll take you to, assuming that you are already logged in, that will take you to the CloudFormation page inside of AWS, and it'll automatically populate this field down here with a pointer to the actual location for the master template for us. All right. The next step here would just be to hit Next. I'm going to go to a region. Our product isn't available in almost all regions. I think the only one we are currently not available in is Asia Pacific, Tokyo, but it should be available everywhere else. So I'm going to go to London. I don't believe I have any resources in London currently, so I should be able to push this entire template through without needing to worry about it. But as the diagram showed a minute ago, this does require 4 elastic IPs. It does require a virtual private cloud. It does require several subnets and several routing tables to get configured. So one of the things that could hang you up is if you don't have enough available resources in a region that you try to deploy it to. If you already have things there, you could run out of available IP addresses. I think you're only allowed 5, and this template uses 4. I think you're only allowed 3 VPCs in a availability zone or in a region, and this template makes 1, obviously. So if you're already at your VPC limit, if you're already at your other EC2 limits for IP addresses or whatever, then the template may fail. But you can request to Amazon to extend those limits for you, and those limits do change occasionally. So it might be a good idea to keep an eye on that if this is something that you are doing. All right, so one of the things that you're going to do, I'm going to change this so that it matches the deployment I'm going to show you in a minute. I'm going to change the name to just SIOS. This is basically all the information that matches that diagram. These are the parameters you need to specify. I'm in London right now, so it only has 2 availability zones available, EU West 2A and EU West 2B. So you would select those. This template only works on 2 resource groups or availability zones at the moment. So you would just select those. And then the rest of this is auto-propagated for you. You can change this if you have a different design in mind. If you've already gone through and you're planning on having a whole lot more private subnets so that you can have a whole lot more failover cluster instances. So you could have like a 2-node cluster and 1 pair of subnets and a different 2-node cluster in the same 2 availability zones. You would need more subnets, right? So you could tweak this to meet that as well. After that, this key pair name, typically the way the communications and logging into VMs works in AWS is you create a security credential key pair for your admin user, and then they can log in by using that key pair to decrypt the password on the VMs when they're spun up. This template, creates a domain and then registers all the nodes with the domain. So this isn't needed here, really, unless the template fails to deploy and you want to keep the nodes around. So it's not really an important parameter per se, but you'll need one to fulfill this and to help you log into the machines if they fail to get domain joined. So we've got this Microsoft Active Directory configuration. This template actually relies on several other templates that AWS has put together. One of them is the Active Directory stack. These are parameters that you need for it. We've gone ahead and populated these with the most common, in our opinion, things. We've set the domain controller size to a T2 large, which is in the small end of that scale. We've given it a name. We've given it its private IP addresses. We've done that for both the primary and the backup domain controller. We've put in a default domain name, but if you wanted to change this to something else, AWS templates typically use example.com, for instance. But whatever you choose, it's going to matter, and it's going to change the way that you log in. So I'm just going to leave this as datakeeper.local and datakeeper as the domain name BIOS name so that it's the same with the one that I've already deployed to show you. You could set a restore mode password, so you would just come up with something, plug it in there. This is your domain admin name. You would choose something for that, and then you would give them a password. Whatever you type in here will be in the domain datakeeper, obviously. So you'll need to remember that in order to log in, you'll have to use this domain / your admin username, and then you'll have to use your password. All right, allowed remote desktop gateway external access CIDR. This is something typical to most AWS templates that rely on some kind of application that you're deploying. This is typically used for enhanced security. Say you don't want anyone to log into any of your nodes, not even the jump box node, which is slightly public facing, from anywhere except your building's IP address. That's what this is for. You can set this to something, and nodes from not inside that CIDR block will not be able to access that node. So ours is something like 75.168.92, and then I would do 0 and 255 or 24. It is in CIDR notation, so it would look like that. You would have some kind of public IP address range, and in this case, it's any address in the space given there. For purposes of this demo, I'm going to use this IP address. That is pretty much the anybody can access from anywhere IP address. So if you don't want to limit it, and you have people all over the world that need to access the jump box, or you have your major person doing this is a traveling salesman effectively, then they'll need to have an open access port. Then the size for the remote desktop gateway instance at this point is this. All right, so replication configuration. This is useful for our product. You will need to have a URL for our license. That is typically something that looks like this. And then basically whatever the rest of the string is for the URL for that. This is your SQL service account name, the SQL admin that you're going to use for this box, and then they're going to have a password. And then the rest of this is, again, it's auto-filled. This is the size of your data volume. So if you've got a terabyte of storage that you need to put in the cloud, you could just set that to a terabyte of storage. It's in gigabytes. So this is configurable as well. I'll just leave it at 100 so it matches again. If you need to use really fast drives that have very low latency, you can switch this to an IO1 type of drive, and then you can specify the IOPS that you want. If you leave it on GP2, then the IOPS don't matter. It just gets ignored. Then you come down here and you start configuring your failover cluster instance nodes. They're, again, filled out for you with all the things that are in that drawing earlier. The name of the node is going to be WSFC1 for the primary one and WSFC2 for the backup. They're going to be R3 extra larges. Typically, we do this with either R3 extra larges or M3 extra larges, and they deploy in approximately an hour and 50 minutes. Down here, these are kind of esoteric. If you want to modify this template at all and use it over and over again, say you want to make sure that the template doesn't change over you. These are living documents. For case in point, in between the time that the website was published a couple weeks ago with that diagram up there, Amazon has changed their remote desktop gateway template that this relies on. So now you only have one remote desktop gateway server instead of two. So that's why you only have one size here and one, I guess that would be one anyway. Previously there were a lot more things here and you had two like in the diagram, but now you just have one, so you're not paying for an extra node that you don't need. This is basically an S3 bucket, and this is a folder in that S3 bucket. If you wanted to download these resources to your own central repo so that you know that they will never change, you can do that and then point these at your private S3 account bucket and the folder inside of that you put those in. These templates live in GitHub, basically, and this is going to reference behind the scenes the actual S3 buckets that AWS themselves use and clone from GitHub to where they want to keep them. So we don't need to change those, but again, if you had your own copy of this locally or in your local account, you could change these to point to that. I'm not going to worry about it. It's going to go next. Again, there's not really much here. You can specify some tags if you want to, some names that you will see in the EC2 panels, but there's not much I have to do for this. And then you can go and review all of this. You can see the description of what this thing does. It deploys 2 server failover cluster nodes with SQL Server 2014 and DataKeeper, etc. And then it gives you a warning that it creates a whole bunch of stuff and that you'll be charged for most of them. And then you can roll down here. There's this, yes, you acknowledge that this creates a whole lot of stuff and that all of that is billable. And then you click create. All right, that pushes the stack into CloudFormation, and you will start seeing things that look like this, right? You can see the events, you can see it in progress. By going here, the first thing it's going to do is it's going to create a VPC stack. It should already be started. Here you go. And then you can follow the VPC stack creation progress. And basically you can go have a cup of coffee, tea, whatever your preference, and twiddle your thumbs for 2 hours and wait for that to work. Right, so most of the template as it stands with all the parameters that I just showed you, I talked a lot about all of them because I wanted to make sure I covered them. But for the most part, I really only needed to talk about maybe 5. I really only needed to make changes to the 3 password fields that are there, the recovery password, the domain admin password, and the SQL password. I needed to give it a pointer to the SIOS license, which when this template supports the pay-as-you-go licenses, it will no longer, you'll have the option and not need that either. So next week or so, you will only need to maybe change 4 fields on that entire document, and it will work out of the box for most deployments, for greenfield, proof of concept, any trials that you want to do. Almost anything that you can do that's not specified would just work out of the box as long as you're not deploying it to a region that's already got a whole bunch of stuff spun up into it and you're running into resource contention. All right, so I'm going to move on to one of these that I spun up this morning. Go to the CloudFormation page for that so you can see what the thing looks like when it's done deploying. All right, so I spun this one up in Northern California as opposed to the one we just did in London. When it's done, you will see this is the master template being pushed. It goes through, and the master template is in charge of creating these 4 stacks. It creates a stack for the VPC, it creates a stack for the Active Directory domain controller stuff, one's for the remote desktop stuff, and then one for our SIOS product. So if you wanted to go back and look at that drawing, this one here is the gray box that I was mentioning that you could deploy by itself. So if you were to use the other template that we showed you, the only one of these you would see is this last one. But again, you would see all the things that it does for you. And just to give you a brief idea what's going on, there's some wait handles to make sure it works, security groups, some volumes, some ingress rules. This is your security stuff. This is doing a lot of things, right? There are a lot of events in here that are happening. Then you finally get to the actual instances. You want to spin up some data volumes, attach those volumes, and then after you get to about here, everything else is configuration. You can see that like most of it's done within a few minutes. Like this template was started at 10:56 Eastern Time, and by 10:59, 90% of this template was done. After that, it was just configuring the actual nodes. So I'm going to go show you what those actual nodes look like, and then we'll open it up for some questions. All right, so typically you would go to your EC2 panel, find the remote desktop jump box that it gave you, and you would basically launch RDP to that box. It's going to come up and ask you what your domain name is. Let me bring that on the screen so you can see it. All right. You're going to have to tell it the domain that you gave it. This is the default one that's in the template, along with the default admin name. Whatever password you typed in would go there, and then that'll log you into the jump box, and then from the jump box, once it logs in, I'll bring it over. From the jump box, you would do something similar. You'd have to remote in, obviously, to the other nodes. The default IP address for the node 1 is 10.0.0.100. And again, it's a domain join node, so you would just log in with the domain credentials you gave the template. And now we are jump boxed into node 1. For purposes of just showing you that everything got spun up and working, open failover cluster. You can come down here and you can see what roles you've got. You can see that it installed a SQL Server instance. You can see that it's got some SAMless DataKeeper storage here. You can see that you've got 2 nodes in your cluster. And you can fail this over. Currently it is in node 1. If you wanted to move it to node 2 because you had maintenance to do on this node, you could just go here and move it to the other node. If you've got more than one, you can select which one. But for this template, it just does 2. So select best node, we'll just switch it over to the other one. Give it a few seconds. You can come down here, you can see what resources actually belong to the SQL Server instance. This is a multi-subnet SQL Server instance. So you will have 2 here. You'll have one for the first node and one for the second node. Whichever one that happens to be online will be the one of these IP addresses that is online, and then your SQL Server, and it's done. So anytime you need to switch over, you can just do that. If it fails, obviously it'll do that automatically. All right, and that's pretty much it for the deployment. Again, it takes about 2 hours, and you can come back and see that. So I'm going to minimize this and go back to our presentation. Turn it back over to Cassius.
Thanks, Heath. So as Heath showed, and we'll kind of go through quickly because I know we're up short on time and want to at least get to some of your questions, just showed you really quick, you single click and there are about 4 fields that you need to change just for security purposes of defining a password. And then you have a ready-made SQL Server standard edition cluster available in the cloud for your proof of concept or your production workloads, and that automates and makes it a lot easier for you to begin to make the transition to the cloud. Before we go to questions, just want to give you a little bit about SIOS. We founded in 1999, headquartered in San Mateo, and have over 60,000 licenses installed globally in a wide range of industries. We have our production suite for Linux and Windows, and featuring SIOS DataKeeper for SAMless cluster solutions. For additional information about SIOS technology, for free trials, or for information about anything that you heard mentioned here regarding SAMless clusters, AWS quick start deployments for SAMless clusters, or our other SIOS product suites, you can contact us. Either go to the website and look for contact us or information there, or email us at info@us.sios.com. So I'm going to turn it back over to Greg. I'm not sure how much time we have left for questions, but want to open up the floor for any questions that may have come in during the presentation.
All right, thanks Cassius and thanks Heath. All right, there are a few questions. So I guess the first question is there a quick start guide that people can access to kind of look at those 4 things you identified and any other settings for the templates?
Yes, actually, if you go back to the AWS Quick Start page itself where we launched the template from, there's a link just below the one that we used that has the Quick Start guide for it. And it explains all the parameters that are needed for it and what they're for and what all the actual resources are in there.
Okay, great. And then another question, is there a cost for somebody to set up a development test environment on AWS, and how does that work as far as setting this up?
Okay, so the easiest answer there is that there is a cost for the Amazon resources if you're spinning this up in terms of what you saw with the template. But there are also some options for the cost if you're doing a proof of concept environment. And there are pointers on our website for contacting SIOS to allow customers that are wanting to try and get a free trial for the SIOS portion of the Amazon instances in the cloud. You can get information there, and our team will contact you about getting the free trial of the SIOS DataKeeper solution. The Amazon machine instances typically run as in a pay-as-you-go model during the trial of the software for SIOS DataKeeper.
Okay. All right, another question somebody asked was, are Stainless clusters available in native SQL Server, or do you need the SIOS DataKeeper product?
So Stainless clusters, you need the SIOS DataKeeper product to enable Stainless clusters for SQL Server. There are some additional options if you're wanting to go on an enterprise to try to do, as we mentioned, the availability groups. But for Stainless clustering solutions in the cloud, you have to purchase the SIOS DataKeeper product.
All right, great. Well, that's about it for the questions. So, and we're a little over time anyway, so just going to wrap things up. So as you can see on the slide here, if you're looking for some additional information, please visit the SIOS website at us.sios.com. And there's other information out on the website as far as what was discussed today. And you can use the email there or call them for more information about SIOS DataKeeper and getting DataKeeper up and running on AWS. The webcast was recorded, and you'll receive a follow-up email with links to view the archive. We'll get that set up later today, and I'll try to get a copy of the slides from Cassius and Heath that we can post on the website as well. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and have a great day.